In this video, I'm going to get you started on how to do half reactions for the following. So this is our classwork for our half reactions topic, or at least part of the classwork for our half reactions topic. So the first thing you have to do when you look for half reactions is you have to assign the oxidation numbers and look for a change. So just to review your rules real quick, elements, or we call them free elements, but elements are always zero. So even though oxygen has its own rule, when it's in the elemental form as O2, it's zero. Same thing with Hg. When it's in a compound, then the -2 kicks in, which makes Hg plus 2. All right, then the next thing you're going to do is look for a change. So in other words, there's only two elements here in this problem, so finding the change is very easy. Hg changed. It went from +2 to 0. And so by doing that, so if we remember our saying, Leo goes gur, or Leo the lion goes gur, lose electrons is oxidation and gain of electrons is reduction. So in this case, this one gained electrons. So it is going to be reduction because it gained 2 electrons. Now, oxygen went from -2 to 0, which is lose electrons, oxidation, which means it lost 2 electrons. A little bit hard to write in there, but hopefully you can follow along. So oxidation was going to be the oxygen. Now, to write the half reactions, it's pretty simple. You erase everything but the elements involved. So in this case, it's Hg plus 2. And it is going to turn into Hg0. All right. Now the question is, it gained 2 electrons. So since it's gaining electrons, I'm going to add them to the left of the arrow. So there's my 2 electron gain. Then for oxygen, I'm going to write it out like this. Now notice, it says O2 here, but I'm just writing oxygen. And the reason is because when we do our half reactions, we are going to oversimplify them and only draw them for a single atom or ion. So in other words, we call it an atom here, we call it an ion here, but you get the idea. So for a single, we're only doing it for a single atom. You can do full half reactions for balanced equations, but that's more complicated and it isn't necessary for this class. So that's why I'm going to kind of skip over it. I know in the notes, I believe I did show you how to draw the real full half reactions, but we're not. I'm skipping over that from this point on. So since oxygen lost 2 electrons, I add it to the left, or I'm sorry, the right. And then, and again, this is the idea of, we know Leo gur, and we know that when you're gaining it, stuff that's going into the reaction, it goes on the left. And if it's leaving the reaction, or if you're losing it, it goes on the right. And that's where that comes from. And then the last part is balancing with coefficients. So you put parentheses around these guys. And now you just need to say, what do I have to multiply them by to make the electrons gained equal the electrons lost? And since it's 2 and 2, then the multipliers are just 1 and 1. And that's a balanced half reaction. The next one I want to do is going to be the bonus all the way at the bottom. So the reason I'm doing the bonus is one specific issue. So normally we have rules for most of these. So like 2 won't be a problem, 3 won't be a problem. When you get to 4, 5, and 6, here's the issue. I'm using chlorine instead of fluorine. And the thing you have to understand is when halogens are in compounds, fluorine is always -1, but most halogens are usually -1. Notice the language change there. So for 4, 5, and 6, the chlorines, when it's in a compound, we're going to assume it's got the same oxidation state as a fluorine, which is a safe bet most of the time, which is why I'm telling you that now. So I assigned a -1 charge for all my chlorines because they're all in compounds. If it was alone as a Cl2, then it would be a 0 because it's an element. Then I figure out my Sn and my Fe's. So my Sn here is going to be +3, +3, +2, plus 4. So those are my oxidation states. Now I need to find the one that lost and the one that gained. So it's clearly going to be Sn and Fe because Cl stayed -1 the entire time. So it turns out that Sn actually, did I keep it in the right color? Nope. Let's make that green. Doesn't really matter because you're going to be doing this at home and you don't necessarily need to use 2 colors. I just want to try to keep it color coded. So Sn lose electrons. In other words, it was oxidation. The reason I know that is because it went from +3 to +4. So that's actually losing an electron, which means that Fe must have gained some amount of electrons, not necessarily 1. So Fe in this case did gain 1 electron, which is gain electrons reduction. So Fe gained. So we write, pen looks like it's running out. So there's my reduction. And now let's do the reaction. So it starts out as Fe plus 3. And then I know it's going to gain an electron. So I'm going to leave a little bit of space here to put my 1 electron. And I know it gained 1 because it went from +3 to +2. And it turned into Fe plus 2. All right. And then for oxidation, my Sn was +3, and it turned into +4 by losing an electron. Now again, balancing wise, these are easy ones to balance because they're gain and lost 1, so it's just 1 in each case. The reason this one was a bonus was because normally if you look at all the problems, these are typically considered single, most of them are single replacement reactions, not all of them, and so you end up getting the ones with zeros, the ones that have that are elemental, are oxidation state 0. Those guys are almost always your answer, meaning I can tell you right now, for half reactions, it's going to be zinc and iron, and copper and zinc, because those are the ones that go to 0 and then they change to be in a compound where they can't be 0. So they go 0, not 0, or not 0, 0. Those are changes, so it's very easy to look those up. In 6, none of them went to 0, so you had to actually assign the oxidation states for every single one of them correctly, and you needed to be aware that the chlorines were going to be -1s. And also, just to mention it one more time, for 4 and 5, the chlorines are going to be -1 because they are halogens and they're very similar to F, so they very often take on the -1 charge.